Good day and welcome to our today's class. In today's class, we want to prove that a monotone sequence converges if it has a convergent subsequence. A monotone sequence converges if it has a convergent subsequence. That implies that given that A sub n is monotone, given that A sub n is monotone, if A sub n has a convergent subsequence, then A sub n converges. Then A sub n converges. Now recall from the monotone convergence theorem. Recall the monotone convergence theorem, which says that a monotone sequence is convergent. A monotone sequence is convergent if and only if it is bounded. But monotone implies that what? When we say a sequence is monotone, it implies that the sequence is either increasing or decreasing. Now let A sub n be an increasing sequence. Let A sub n be an increasing sequence. Therefore, by the monotone convergence sequence, if A sub n is increasing, and converges, then A sub n is bounded. That implies that what? A sub n has a supremum. It further implies that A sub n converges to its supremum for all epsilon greater than 0. Now let A sub ni be a convergent subsequence of A sub n. Let A sub ni be a convergent subsequence of A sub n. That implies that what? A sub ni converges to a limit That implies that A sub ni converges to a limit. But A sub ni is the subsequence of an increasing sequence. Is the subsequence of an increasing sequence. That implies that A sub ni is also increasing. You remember from previous theorem that if an increasing sequence, then it will have an increasing subsequence. And that implies, if it is increasing, that implies that A sub ni is monotone. That implies that A sub ni is monotone. But we have said that A sub ni is convergent. But A sub ni is convergent. It further implies that A sub ni is therefore monotone and convergent. And if A sub ni is monotone and convergent, by the monotone convergence theorem, by MCT, then A sub ni is bounded. By MCT, A sub ni is bounded. And since A sub ni is increasing, then A sub ni is bounded above, since it is increasing. And since it is bounded above, it means that what? A sub ni has a supremum. It implies that A sub ni has a supremum. And if it has a supremum, it further implies that A sub ni converges to its supremum. A sub ni converges to its supremum since A sub ni is convergent. That implies that what? The limit as I tends to infinity of A sub ni is equal to the supremum of A sub ni. Is equal to the supremum of A sub ni. Now we want to show that A sub n also converges to the supremum of A sub ni. We want to show that A sub n converges to the supremum of A sub ni. We want to show that A sub n converges to the supremum of A sub ni. But remember, we have said that A sub n is monotone or monotone increasing, since we said let A sub n be an increasing sequence. Now consider an arbitrary term. A sub p of A sub n. This then implies that what? A sub p will be less than or equal to A sub p plus 1, since the sequence is increasing. since the sequence is increasing. Also consider an arbitrary term A sub nj of the subsequence A sub ni, where nj is greater than p. This implies that what? A sub p will be less than or equal to A sub nj. Remember, our A sub nj is a term in the subsequence of A sub ni. But A sub ni has a supremum. But A sub ni has a supremum. Then it implies that what? A sub nj will be less than or equal to the supremum of A sub ni for all I belonging to the set of natural numbers. And that further implies that A sub p will be less than or equal to A sub nj, which is less than or equal to the supremum of A sub ni. But A sub p is a term in the sequence A sub n. Therefore, the supremum of A sub ni is an upper bound. Is an upper bound for A sub n. And the first term of A sub n will be its lower bound. That implies that our sequence A sub n is bounded, since it has what? Both upper bound and lower bound. And remember that A sub n is monotone. It further implies that A sub n is monotone and bounded. A sub n is monotone and bounded. Therefore, if A sub n is monotone and bounded, if A sub n is monotone and bounded, then by the monotone convergence theorem, it implies that what? A sub n is convergent. It implies that A sub n is convergent. Then by the subsequential limit theorem, SLT, by the subsequential limit theorem, which says that a convergent sequence has the same limit as every of its subsequents. A convergent sequence has the same limit as every of its subsequents. Then what does that tell us? It implies that what? A sub n converges to the supremum of A sub ni. Converges what? To the supremum of A sub ni by our SLT. And A sub ni is a subsequence of A sub n. And A sub ni is a subsequence subsequence of A sub n. And also, A sub n is convergent. Therefore, by SLT, that's the subsequential limit theorem, A sub n also converges to the supremum of A sub ni. And that implies that the supremum of A sub ni is equal to the supremum of A sub n. Therefore, if A sub n is a monotone sequence, if A sub n is a monotone sequence, and it has a convergent subsequence, then A sub n converges to the same limit as its subsequence. And that ends our proof. Says prove that a monotone sequence converges if it has a convergent subsequence. That ends our proof. If you have gained anything from this video, like, give it a thumbs up, and share with your friends and colleagues. Thank you. God bless you. I see you in the next video.